AQ A-Level Chemistry Paper 3, June 2018. Walkthrough. Section A, I'm going to go through. Section B, the multiple choice questions, I will probably go through them. But I'll do it on my laptop and screen record it because I can actually explain the multiple choice questions because a lot of them require a lot of steps, even though they're all 1 mark. Question 1.1. Explain why the use of a large excess of H2O2 and I- means a rate of reaction at fixed temperature depends only on the concentration H plus aqueous. H2O2/I- concentration is effectively constant, therefore, because a large excess of it, therefore they have no effect on the rate, so it is zero order. Then explain what must be done to each sample before it is titrated with alkali. Stop the reaction by dilution. For titrated with alkali. Explain how the graph shows that order with respect to H plus aqueous is 0, constant gradient as concentration H plus changes/decreases. Calculate value of K1, give the units of K1. I just think about it, they're giving you a graph, they say calculate value of K1, it's obviously going to be the gradient. So M equals Y2 minus Y1 over X2 minus X1, find out the gradient. You get that units multiply minus cube S to the power minus 1. Plot these results in the grid on figure 2, you just plot them. And then draw a line of best fit. Obviously, I just copied from the mark scheme. I don't want to waste time just going through each one individually because all you're doing is plotting them and then draw a line of best fit. But then this 1.7, which I then realized later on, is it wants you to calculate rate of reaction concentration H plus equals 0.35. So then I would need it to be accurate. But all you would do is draw accurate line of best fit in your grid, 0.35, draw a line here, and then you want to make sure that the line is equally here, and then you just calculate your gradient and get your rate. 1.8, a general equation for reaction is shown. In aqueous solution, A, B, C, and D are all colorless, but E is dark blue. A region X is available that reacts rapidly with E. This means that if a small amount of X is included in initial reaction mixture, it will react with any E produced until all the X has been used up. Explain giving brief experimental details how you could use a series of experiments to determine the order of reaction with respect to A. In each experiment, you should obtain a measure of initial rate of reaction. Colorimetry and continuous monitoring. Stage 1, preparation. Measure suitable volumes of A, B, and C. Use of colorimeter into separate containers. Stage 2, procedure. Start clock/timer at point of mixing. Take series of colorimeter readings at regular time intervals. Use the same concentration at B and C, same temperature. Repeat with different concentrations at A, because that's what I'm trying to find, order of reaction with respect to A. Stage 3, use the results. Plot absorbance, use time, calculate M, the gradient. When T equals 0, plot of gradient against concentrations of A, and then interpreting order from shape of 1 over time with concentration graph. Question 2, given an equation, 2 observation made for reaction that occurs with sodium heated with oxygen, 2 Na solid plus half water gases to form Na2O solid. Orange flame, 1 observation, white solid, another observation. Orange flame, 1 observation, white solid, another observation. Given an equation, 1 observation when phosphorus heated with oxygen, P4 plus 5O2 to form P4O10, white flame. Explain the increased melting point for sodium oxide and magnesium oxide. Well, increased charge density in Mg2 plus ions, therefore stronger ionic bonding, stronger attraction between Mg2 plus and O2 minus ions. Explain why the melting point of oxide of silicon is much higher than that of the highest oxide of phosphorus. Silicon dioxide, giant covalent/macromolecular. Phosphorus is simple molecular. Covalent bonds throughout structure silicon dioxide much stronger than the intermolecular forces in between phosphorus, P410. Describe a method for determining melting point sample state, how it will be used to value its purity. Sample in suitable melting point apparatus, for example, capillary and oil bath. Heat gradually to establish melting point range. Melting point range is range of temperature from where a solid begins to melt to where it's melted completely. Lower melting point / broad range of melting point would indicate presence of impurities. Question 3, year 1, practical. From cyclohexanol to cyclohexene. Preparation of cyclohexene from cyclohexanol. Calculate percentage of your cyclohexene, classic question. First things first, what is the formula? Actual yield or theoretical yield times by 100. I'm going to find out the molar cyclohexanol, use the molar ratio to find out the maximum mass cyclohexene, then substitute it in. And because that's going to be theoretical yield, that's the actual yield or theoretical yield times by 176%. Describe a test tube reaction of product showed that cyclohexanol had been dehydrated. Well, if the cyclohexanol has been dehydrated, I'm going to form the cyclohexene, and this has got a carbon-carbon double bond. So, what's the test for carbon-carbon double bond? Bromine water. Add bromine water, turns from orange to colorless / solution decolorizes. And these little test tube reactions, they are really simple, just memorizing them, but in the exam, they put it in unfamiliar contexts. It's like you have to flip back and then identify, I've got carbon-carbon double bond, and therefore. So, even though these questions, you obviously you need to know the test tube reactions really confidently, and then you need to apply it to question and have a look at your question. Suggest why sodium carbonate solution used to wash a distillate. Sodium carbonate would neutralize / react with the phosphoric acid H3PO4. Sodium carbonate neutralize / react with H3PO4. Explain why it's important to open the tap of separating funnel periodically to avoid pressure buildup. Give a property of anhydrous calcium chloride other than the ability to absorb water that makes it suitable as a drying agent. Preparation does not react with cyclohexene. Describe apparatus used to remove the drying agent by filtration to reduce pressure. I'm going to do description. Buckner funnel, a flat bottom funnel containing filter paper, or your Buckner flask, a side-arm flask connected to a vacuum pump. Buckner funnel, flat bottom funnel containing filter paper, Buckner flask, side-arm flask connected to a vacuum pump. Explain why cyclohexene is shorter retention time than cyclohexanol. Cyclohexene is less polar than cyclohexanol, therefore cyclohexene has a greater attraction for the mobile phase. Or you could say cyclohexanol is more polar than cyclohexene, therefore cyclohexanol has a greater affinity for the stationary phase. Explain how infrared spectrum would confirm that cyclohexene obtained from the chromatography column did not contain any cyclohexanol. There will be no additional peaks in the fingerprint regions compared to a pure sample. No additional peaks in the fingerprint region compared to a pure sample. Plot a graph of this. Graph 1, I'm just going to skip this. This one is pretty tricky though. I'm not going to lie. It is a pretty tricky graph question, but I'm going to skip it. 4.2, then you use your answer. You find out temperature rise, and then I know uncertainty for each of these 0.1. So it's going to be 0.1 times by 2 over my answer. And that's the hard part. Remember, it's times by 2 because I've got 2 temperature readings to find the temperature change, and then times by 100 because percentage. Such a change to experiment that would minimize heat loss, use a lid, or instead of using insulated glass beaker with a polystyrene cup, we just say, because it says, where does it say? Get into a glass beaker there. Suggest and explain another change to experiment that will decrease the percentage of uncertainty in the use of the same thermometer. Increase the magnitude of temperature change by increasing the concentration of acid / alkali. Increase the magnitude of temperature change by increasing the concentration of acid / alkali. Given the equation for reaction between ethanediolic acid and potassium hydroxide solution, HOCCOH plus KOH, and what's going to happen? Acid plus base, salt plus water. So my salt, well, because I can see here I've got OH here, right? I'm going to need K2 OOCCOO plus 2H2O. Then calculate enthalpy change per mole of water from this reaction. This one is also a very tricky one compared to these AS questions where it's like calculate enthalpy change per mole, or even A-level ones. First things first, Q equals MC delta T, where M is mass of water. Very easy. M, mass of water, well, 25 centimeters cubed plus 75 centimeters cubed, 1 gram per centimeter cubed density of reaction mixture. So it's just 100 times by 4.2 times by 3.2. Temperature rise, temperature increase by this much. That's Q. Then I need to calculate the moles of ethanoic acid and moles of potassium hydroxide solution, because I don't actually have, because I need to find out the moles of water, right? But I can't directly find that because I've not got anything. But I have got the molar ratio from the equation. Look at the moles of this, look at the moles of this. You can see that's 0.020, that's 0.045, but this should be 0.040 because of 1 to 2 molar ratio. That tells me this is in excess, therefore I do not care about these moles. I'm not going to use it to calculate the moles of this, which therefore would be 0.045. It's in excess, I don't care about these moles. So I'm going to use these moles, 0.020. Well, that's 1 to 2 molar ratio, so therefore I'm going to times by 2, 0.040 for the moles of H2O. And then I'm going to use delta H is Q divided by moles. Q needs to be in kilojoules, in kilojoules 1.344 in kilojoules over the moles of H2O using the mole ratio from ethanediolic acid, because that's not in excess. These moles are excess, so I don't care about these moles, over 0.040. Then I'm not even done there. I get 33.6, but then I need to put a negative sign because the temperature increased, therefore it's going to be exothermic, and you need to do that as well for 5 marks. Suggest an explanation for the difference between this value and answer to question 4.5. Sulfuric acid and potassium hydroxide was this, and mine, ethanediolic acid, potassium hydroxide. Well, I know ethanediolic acid, well, I should know, sulfuric acid is a strong acid, ethanediolic acid, HOCCOH, is a weak acid, therefore not fully dissociated, so more energy needed to break bonds, and dissociation is endothermic. And that is the end of section A.